The only solution to x squared plus bx plus c equal to 0 is x equals negative 15. Work out the values of b and c for 3 marks. This time we're working backwards to get our quadratic. As I know the only solution in this case is x minus 15. Therefore in brackets it must be the opposite. Opposite of minus 15 is x plus 15. But as we want a quadratic, we know when solving a quadratic, we get 2 solutions. But as we're told the only solution is x equals negative 15. Therefore, that must be a repeated solution, i.e. repeated root. So therefore, my other bracket will also have x plus 15. And that equals to 0. Expanding out my double brackets to get my quadratic. I know x times x will give us x squared. X times positive 15 will give us plus 15x. Positive 15 times x will give us another plus 15x. And 15 times 15 will give us plus 225. And that equals to 0. Collecting like terms on the left, we've got x squared. No other term ending in x squared, so I'll write that down. I've got plus 15x plus now 15x. They're like terms as they both end in single x. Well, 15 add 15 gives us 30, so I've got 30 lots of x. I've still got plus 225, and that equals to 0. Hence, my value for b is the number in front of the single letter of x, in this case 30. And my value for c is my number term, in this case 225. Convert 0.61, as I've got a dot just above number 1. That means that number 1 keeps on reoccurring to a fraction. Hence, my first step is I let x equal my original number. So x equals 0.61, where the 1 keeps reoccurring. My goal is to get the recurring numbers matching at the decimal point. And here, my recurring numbers is just the 1. So my first step is I'm going to multiply the left and the right-hand side by 10 to keep the equation balanced. On the left-hand side, 10 times x will give us 10x. And on the right-hand side, 0.61 reoccurring times by 10. That will give us 6.1, where the 1 keeps reoccurring. Always get decimal point fixed, as my goal is to match up the recurring numbers after the decimal point. Well, clearly here at the moment, they're not matching. So I'm again going to times the left-hand side and the right-hand side by 10 again. On the left-hand side, 10 times 10x will give us 100x. And on the right-hand side, 6.1 reoccurring times by 10. That will give us 61.1, keeps on reoccurring. Now I've achieved my goal of getting the recurring numbers after decimal point matching. I can just simply subtract upwards the left and the right-hand side of my equation. Subtracting up on the left-hand side, I know 100x subtract 10x will give us 90x. On the right-hand side, subtracting up, I can see the 2 recurring parts after decimal will simply cancel. Hence, I've just got 61 subtract 6, which gives us 55. As I want to get x by itself, I know a number in front of the letter means to multiply. So the opposite of times by 90 is divide both sides by 90. On the left-hand side, 90 over 90 will cancel to leave us with single x, which is exactly what I wanted. On the right-hand side, 55 over 90, I can see they're both divisible by 5, as they both end in 5 and a 0. 55 divided by 5 gives us 11, and the bottom 90 divided by 5 gives us 18.